Welcome back, everyone. Today, we're diving into an incredibly important explainer on requirements engineering. Before we can even begin to think about writing brilliant algorithms or designing these elegant system architectures, we absolutely have to start here. You can kind of think of requirements engineering as the critical translation layer between messy human chaos and clean, orderly code. It's essentially the process of figuring out, analyzing, documenting, and then double-checking the exact services that a system needs to provide, along with any constraints on how it operates. So today, we're going to look at exactly how we extract those critical needs from the real world.
Here's our roadmap for today. We'll start with an introduction to requirements processes, look at the challenge of elicitation, walk through the elicitation cycle and elicitation techniques, discuss using stories and scenarios, and finally, wrap up with a summary and exam focus.
All right, Section 1, Introduction to Requirements Processes.
I really want to emphasize something crucial right out of the gate here. This step is absolutely mandatory before you even open your IDE. Seriously, you could write the most beautiful, highly optimized Java code in the world. You could perfectly sort a massive data set of objects using an array list and a highly complex custom comparator. But if you do all of that without actually understanding what the client needs, your perfect code is a complete failure. If you solve the wrong problem, the software fails. It's really that simple. And that is exactly why requirements engineering is the absolute foundation of everything we do.
A very common misconception among students who are learning software engineering for the first time is this idea that you just gather requirements once at the very beginning, write them down in a massive document, and, well, you're done. But in reality, it doesn't work like that. It's a highly iterative process. Think of it like a spiral. We start right at the center, focusing on high-level business goals and broad user requirements. Then, with every loop we make around that spiral, moving outwards, we gather more and more detailed system specifications. We continually discover, specify, and validate. It's this ongoing, continuous cycle of refinement.
Moving on to Section 2, the challenge of elicitation. Now, elicitation is simply the act of drawing out information from people. Sounds super easy, right? Just ask people what they want. But it's actually incredibly difficult because of the messy reality of human stakeholders. First off, stakeholders often don't actually know what they want from a computer system, except maybe in the most vague, hand-wavy terms. A huge pitfall for students is assuming users are just going to hand you a perfect, logical blueprint of their needs. Let me tell you, they won't. Second, they use heavy domain jargon that you, as the software engineer, might completely misunderstand. Third, any given system has many different stakeholders, and they frequently have entirely conflicting needs. And fourth, never ever underestimate office politics. You'll literally have managers demanding specific features simply to increase their own influence in the organization.
So let's recap that. We have stakeholders who don't really know what they want, who speak in confusing jargon, who argue with each other, and who play office politics. How in the world do we possibly make sense of this human chaos? While software engineers don't just guess, we rely on systematic, structured tools to tame this exact chaos.
That brings us to Section 3, the elicitation process cycle.
To transform all those messy human ideas into an organized draft, we use a continuous cycle of elicitation and analysis. Think of this like an engine. It starts with discovery, moves right through classification and prioritization, and ends with documentation, only to loop right back around to the beginning. And the beauty of this is that the engineer's understanding of the system improves with every single loop of this cycle.
Let's formally lock in these 4 phases. Step 1 is discovery and understanding. This is where you're actually interacting with stakeholders to find out what they do. Step 2 is classification and organization. This means taking that giant, unstructured mess of notes and grouping related requirements into coherent clusters. Step 3 is prioritization and negotiation. Remember those stakeholder conflicts we just talked about? This is where you resolve them, getting everyone to compromise. And finally, Step 4 is documentation. This is where you create the actual draft document or update the shared wiki. By the way, notice the spelling here, organization and prioritization with an S. That is standard South African English spelling, and you'll definitely want to remember that format for your exams.
All right, Section 4, Elicitation Techniques Explained.
The real trick here is knowing exactly how to perform that very first step of discovery. And our first tool in the toolkit is interviewing. We define this as formal or informal discussions with system stakeholders to ask questions and derive requirements from their answers. It is a fantastic way to get the big picture directly from the people who will use or manage the system. Plus, people generally just love talking about their work.
Now, there are basically two extremes when it comes to interviews. On one side, you have closed interviews, which use a strict, predefined set of questions. On the other side, you have open interviews, which have absolutely no predefined agenda. They are purely exploratory. In reality, you're almost always going to use a mixture of both. You definitely need some springboard questions to keep the conversation somewhat focused, but you also have to remain open-minded enough to let the stakeholder explore unexpected issues that pop up naturally.
But here's the catch. Interviewing has a massive blind spot. People constantly leave things out because they honestly think they are too obvious to even mention. That's why our second tool is ethnography. By definition, ethnography is an observational technique where you immerse yourself and literally watch people doing their job in their actual environment. This is vital because it reveals what people actually do on a day-to-day basis, rather than what the official company manual says they do.
To really contrast the two, interviews are great for the big picture, but they are terrible for uncovering hidden organizational politics or those implicit everyday habits. Ethnography, on the other hand, is perfect for discovering those implicit habits. Take the textbook's example of air traffic controllers. It's a great example. If you just interviewed them, they'd probably say they use the official conflict alert system exactly as per the manual. But an ethnographer sitting quietly in the control room would observe that they actually just switched the alert off because it's way too sensitive and distracting. They rely on their own visual strategies instead. An interview would never, ever uncover that reality. Only ethnography can do that.
Section 5. Using stories and scenarios.
So, interviews capture the big picture and ethnography captures the implicit habits. But what happens when you sit down with a stakeholder and they just completely freeze up? We call this the blank canvas problem. It's really hard for most people to imagine a system that doesn't even exist yet. To solve this, we use a story. This is a high-level natural narrative description of how a system might be used in real life. Humans are just naturally wired for storytelling, so stakeholders find it so much easier to relate to these than to some dry, bulleted list of features. For instance, the textbook discusses the I-Learn system. Instead of asking stakeholders for data transfer protocols, you create a relatable story where users are discussing sharing photos of their science experiment with the class. It instantly makes the requirement relatable, concrete, and clear.
Once you have that natural story flowing, you can translate it into a scenario. Think of a scenario as the formal, highly structured counterpart to the story. It basically takes that high-level narrative and breaks it down into a specific, step-by-step interaction with the system.
A proper scenario systematically breaks down an event into 4 distinct parts. Step 1, the initial assumption. What is the exact state of the system before we even start? Step 2, the normal flow. What is the expected happy path sequence of events? Step 3, what can go wrong? How do we handle errors or concurrent issues? And step 4, the final system state. What does the system look like after the interaction is completely finished? So, to put it simply, stories get the stakeholders talking naturally, and scenarios structure those messy thoughts for the engineering team.
Finally, Section 6, Summary and Exam Focus.
We've covered a ton of ground today, so let's lock in your direct exam deliverables. What do you actually need to know? Well, you must be able to draw and explain the 4-step elicitation cycle. You need to confidently contrast the strengths and weaknesses of interviewing versus ethnography. Keep that air traffic controller example in your back pocket. You also must know the exact definitions of elicitation, ethnography, and scenarios. And lastly, remember the spiral model. Requirements are a continuous, iterative process, not a one-and-done event. Remember, before you can ever catalog your data or write your logic, you absolutely must thoroughly document these human needs.
Ultimately, elicitation is about listening, observing, and structuring human needs long before any technical design ever begins. If you can master this, you ensure that the brilliant code you eventually write actually solves the right problem. So, with these brand new tools in hand, are you ready to translate human chaos into orderly code? We'll see exactly how we take these documented requirements and turn them into concrete system models and architectures in our next explainer. Thanks so much for learning with me today.